Welcome to The Explainer. This one is proudly brought to you by Forge College. Today, we're mapping out the Capstone overview and integration plan for deploying a comprehensive Solana application. Let's get right into it.
Okay, so I know some of you are probably still sweating from diagnosing those cross-program invocation failures in the previous lesson. Hey, we've literally all been there. But honestly, that specific trauma is exactly why we need a rock-solid plan today. Mismatched layouts during a CPI call are basically the silent killers of Solana programs. So before we write a single line of production code for our Capstone project, we are getting our architectural strategy absolutely straight.
Here's our agenda for today. First, the blueprint metaphor. Then, mapping responsibilities, followed by version discriminators, a profile account example, and we'll wrap things up with the integration checklist.
All right, Section 1, the blueprint metaphor.
I want you to think of your Solana program as a house built from a blueprint. The Solana program template acts as the architectural shell, right? It's the foundation, the rooms, the wiring channels. Each room represents a specific program module or an account type. And Borsh-serialization, well, that's essentially how you pack the furniture inside. If another program, like an external CPI caller, opens the door expecting a nice chair in the northeast corner, Borsh ensures they actually find that chair, and not just some unparsable stack of digital boxes.
This analogy brilliantly illustrates how we need to think about future updates. Say you want to update an account struct. Are you making a cosmetic change, like just adding a folding table in the corner? That's basically the equivalent of adding a trailing optional field. People looking in the doorway really won't mind. Or are you making a structural change, like tearing down an entire wall? That requires a proper layout migration. Without it, you are completely breaking a CPI caller's expectations, which, you guessed it, sets off a massive chain reaction of failures.
Moving on to Section 2, Mapping Responsibilities. We highly recommend mapping your specific files directly to their exact responsibilities. This is absolutely crucial to prevent accidental logic duplication or, even worse, total layout disasters down the road. For instance, your entrypoint file is strictly your raw dispatch. Your processor file is where you match instructions and invoke try from slice. Your instruction file holds the payloads. Your state file houses those Borsh structs we talked about. And your tests folder is where you serialize your flows. Knowing exactly where these touchpoints live means you know exactly where to put your version checks. It just keeps everything incredibly organized.
Which brings us perfectly to Section 3, version discriminators. You need to treat every single account struct as a public-facing room with an explicit sign on the door. That sign is your version discriminator. By placing a small numeric version field right at the very start of your serialized data, CPI callers instantly know how to read the room. If a caller deserializes the layout and spots a version mismatch, it fails immediately. It throws a clear error code instead of silently mangling the data and totally ruining your weekend. Honestly, doing this dramatically reduces your diagnostic headaches. It's a real game changer.
Let's look at a practical application in Section 4, Profile Account Example.
Building this out follows a strict, linear workflow. It starts with laying the initial Borsh floorboards in Step 1, which means defining that struct and its version discriminator. Then, you wire up the deserialization in the processor for Step 2. Step 3 is calculating the maximum size for rent allocation. Step 4, you actually plan out your inevitable version upgrade path ahead of time. And finally, Step 5, validate it by intentionally throwing malformed bytes at it. Seriously, try to break it. This process makes your Capstone project absolutely bulletproof.
Now, let's consider the sizing math for a second. Our profile account needs a username, right? Which is a variable length string. Because of this, we can't just guess the room size. We absolutely must calculate the maximum footprint for our rent allocation. You compute it, you document it in the template's README, and you set that as the single source of truth. No guessing games allowed here, guys.
And since you just mastered debugging CPI failures, you can now write tests that actively attempt to break those layout boundaries. You're going to simulate external reads, you'll intentionally send malformed bytes, and you'll verify that crystal clear error codes are surfaced. You want your diagnostics to scream if something fails. Hook all of this up to a CI pipeline to catch layout changes automatically, and you will never end up blindly deploying a broken upgrade.
Finally, Section 5, the integration checklist.
These 3 artifacts are the exact deliverables you must carry forward into the build phase. You need your inventory table mapping files to jobs, your versioning and migration checklist, and your automated test suite for CPI scenarios. Having these guarantees that your Capstone customization isn't just some exploratory hacking.
It ensures it's entirely traceable, testable, and maintainable for the long haul.
So before you pour the digital concrete, I want you to ask yourself, is your blueprint fully mapped? Because in Web3, a badly placed wall doesn't just look ugly, it literally permanently locks user funds. Treat your template as your master wiring diagram. To dive deeper into this subject and master other incredible Web3 topics, make sure to visit forge.college. Thanks so much for learning with Forge College today. Keep building, and I'll catch you in the next explainer.